Hello students, welcome to my channel. In my last video, I have discussed about the laws of indices. Today I will show you how to apply those laws for solving different problems. Here I have taken a simplification problem. This is the expression what has to be represented in the simplified form by using the laws of indices. So let's see how we can do this. In the first step, we have to copy the expression what is given to us. Let's do this very carefully. Okay. Now just see the expression, all the terms of the expression. Look, this first term can be written as 8 to the power 1 by 5, right? Whole to the power 5 by 2 is already there. Into 16 to the power minus 3 by 2. Okay. Now, if you observe the first term, you can see here we can apply the law a to the power m whole to the power n equals to a to the power mn, right? So, applying this law, we get 8 to the power 1 by 5 whole to the power 5 by 2. That is 8 to the power 1 by 5 into 5 by 2, right? Into 16 to the power minus 3 by 2 is written as it is. Now, these 5s are cancelled. So, 8 to the power half into 16 to the power minus 3 by 2. Okay. Till now we have get this expression. Now make sure students, if you want to apply the laws of indices, you must get the terms with the same base, right? So here look, in this problem we get this opportunity because 8 and 16, both of them can be represented as the power of 2, right? So let's do this. 8 can be represented as 2 to the power 3 whole to the power half will be there. 16 can be represented as 2 to the power 4 whole to the power minus 3 by 2, right? Now look, again we are getting the structure a to the power m whole to the power n into here also a to the power m whole to the power n structure is obtained. Now what we can do here, yes, I hope you all have got it. We have to just apply the law a to the power m whole to the power n equals to a to the power mn. So here we get 2 to the power 3 by 2 into 2 to the power 4 into minus 3 by 2, right? 3 into half, 3 by 2, 4 into minus 3 by 2, right? So after all cancellations, we get 2 to the power 3 by 2 in the first term and 2 to the power minus 6 in the second term. Now just think over it. Both the bases are same. In the first term we get 2 to the power 3 by 2 and in the second term we get 2 to the power minus 6. Both the terms having the same base. Okay. So which law can be applied for further calculation? Just think over it. Pause the video and think over it. Yes, I hope you all have got it. That we have to apply the law a to the power m into a to the power n equals to a to the power n plus n, right? So here we get 2 to the power 3 by 2 minus 6. Because plus of minus 6 will give us minus 6. That is 2 to the power 3 minus 12 by 2. So 2 to the power minus 9 by 2. Hence this representation, this expression what was given to us is represented in the simplified form. So required result is two to the power minus 9 by 2. So look students, here we have to just be careful about the structure, which structure is given to us, and then we have to relate that given structure with the known laws of indices, and then we have to apply those laws carefully in order to solve them. Now we shall see another very interesting problem. Here also an expression is given to us and we have to simplify this expression by using the laws. Okay, so let's see how to do this. First of all, as I have already told you, copy the problem very carefully. Whatever is given in the question, just copy it. Okay. Now watch each and every term very consciously. The first term is 125. Okay. And the second term is 16. The basis of the terms. Okay. I am telling about the basis. So now look, this 125 can be represented as 5 to the power 3. Because if you break the bases as the in terms of the prime numbers, then obviously it will be more easier for you to understand that which law should be applied here. And also this 16 can be represented as 2 to the power 4. Okay, minus 3 by 2 and whole to the power minus 1 by 6, right? So in this step what we have done, we have just broken the terms as the power of the prime basis. Okay, so now look students, this 5 to the power 3 whole to the power minus 2. Obviously, I know you all have got it, that we have to just use the law a to the power m whole to the power n equals to a to the power mn. So here 5 to the power 3 whole to the power minus 2 can be represented as 5 to the power minus 6, 3 into minus 2. And here also 2 to the power 4 into minus 3 by 2. Okay, here also we get 2 to the power 4 into minus 3 by 2. The same law, a to the power m whole to the power n equals to a to the power mn is applied. And then whole to the power minus 1 by 6. Now here we get 5 to the power minus 6. And here also we get 2 to the power minus 6. And whole to the power minus 1 by 6. Right? Now just look at this expression. A to the power m into b to the power m. A to the power m into b to the power m. Okay? Bases are different but the powers are the same. So can't we write it as ab whole to the power m? Hope you all can remember the law. So we will just do it. 5 into 2 whole to the power minus 6 and then we get to the power minus 1 by 6. Okay. So obviously this can be represented as 10 to the power minus 6 whole to the power minus 1 by 6. Hope you all have got it. Now which law will be applied? Yes, the same one. A to the power m whole to the power n equals to a to the power mn, because we are getting this structure, right? So now 10 to the power minus 1 by 6 into 10 to the power minus 6 into minus 1 by 6, and the 6 will be cancelled and then we get 10, right? So this is the required answer. So look how just by breaking the given terms to the as the base, that is the possible minimum basis, and then just by applying the laws step by step, we have reached to our simplified result. Now let's see another very important problem. In this problem it is given that x to the power a by x to the power b, in both the cases the bases are the same, whole to the power a square plus ab plus b square into x to the power b by x to the power c, here also the bases are the same, whole to the power b square plus bc plus c square into x to the power c by x to the power a whole to the power c square plus ac plus a square, right? And here also we have to simplify. We have to simplify this expression by using the laws. Okay. So what we will do here? First of all, we have to copy. When you are answering the question, you have to first copy it. Okay. So let's copy the expression. What is given? Okay. Now look, just observe. This observation is very important thing. Very much mandatory if you want to solve any problem correctly. First of all, observe each and every term. In the first term, we get x to the power a by x to the power b whole to the power a square plus ab plus b square. So it is obviously clear to all of us, I know, that if you keep the term in this form, especially in this example, you will not be able to reach to the further step. So what you have to do, you have to represent this term x to the power a by x to the power b as the power of x. Because in this case we get in numerator and denominator the same base, right? So here we can write x to the power a by x to the power b means x to the power a division x to the power b as x to the power a minus b. Now whole to the power a square plus ab plus b square will be written as it is, will be kept as it is. Into the same thing will go for second and third term also. b minus c, and here b square plus bc plus c square, and x to the power c minus a in the third term to the power c square plus ac plus a square, right? Now which structure do you get? You are getting the structure x to the power a minus b whole to the power a square plus ab plus b square and so on, right? This type of structure. Now just pause the video and now think which law will be applied here. Yes, hope you all have got it. We have to apply the law a to the power b or a to the power m whole to the power n equals to a to the power mn, right? So here, applying that law, we get x to the power a minus b into a square plus ab plus b square, right? Into x to the power b minus c into b square plus bc plus c square into x to the power c minus a c square plus ac plus a square. Okay. So now this x to the power a minus b into a square plus ab plus b square. If you focus to the power only, you will find this will give you x to the power a cube minus b cube, right? Because we know the formula of a cube minus b cube, that is a minus b into a square plus ab plus b square. Similarly, from the second term, we will get x to the power b cube minus c cube. Okay, from this, and from the third term, we will get x to the power c cube minus a cube, right? Now just look at the expression what you have got in this step. Look students, in all three terms we find the same base, and moreover the structure is x to the power some power into x to the power another power into x to the power another power, right? And we know by the laws of indices that a to the power m into a to the power n into a to the power p equals to a also can be written as a to the power m plus n plus p, right? So just do the same, x to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube, right? All these calculations are taking place in the power of x. So write it very carefully, okay? So these cubes, a cubes, c cube, b cube, all are cancelled. So here we get x to the power 0, okay? And we know any base to the power 0, the base must be a non-zero one obviously, because 0 to the power 0 is undefined. So any non-zero base to the power 0 will give us 1. So hence this result is 1. So required result is 1. And now just see all the steps and also observe how different laws are applied to solve this kind of problems. Now let's say another type of problem, where we find that we have to prove that a to the power 1 by x minus y whole to the power 1 by x minus z into a to the power 1 by y minus z whole to the power 1 by y minus x into a to the power 1 by z minus x whole to the power 1 by z minus y equals to 1. That is, this left hand side of the equal sign has to be proved to be equal to 1, which is on the right hand side. So obviously it is clear to all of us, I know, we have to start our calculation from the left hand side of the equal sign, because more informations are given on the left hand side. Okay, so let's start this. First of all, we are considering LHS, means left hand side. Here we get a to the power 1 by x minus y whole to the power 1 by x minus z into a to the power 1 by y minus z whole to the power 1 by y minus x into a to the power 1 by z minus x whole to the power 1 by z minus y, right? Now, if you see each and every term of this expression, you will find they are giving you the formation a to the power m whole to the power n, right? So it can be written as a to the power mn by laws of indices. So here we get a to the power 1 by x minus y into 1 by x minus z. That is 1 by x minus y into x minus z. Hope it's clear to all of you. From the second term, we will get a to the power, the same thing, 1 by y minus z into y minus x. These two powers will be multiplied into a to the power 1 by z minus x into z minus y, right? expression is obtained. Now just see the entire expression. You will find the structure a to the power m into a to the power n into a to the power p, right? So using the laws of indices, we can write it as a to the power m plus n plus p, as we all know this. So here we get a to the power 1 by x minus y into x minus z plus 1 by y minus z into y minus x plus 1 by z minus x into z minus y. That means all the numbers, all the expressions which were in the power of the bases were the same, that was a, are added here in order to get the result. That is, we have to now just add this 3 expressions in the power of a. Now look at each and every term very carefully. Look students, in the first one we will get x minus y into x minus z. That is 1 by x minus y into x minus z. So you can find that in this expression, the terms are in order, the alphabets are in order, right? So just copy it as it is, x minus y into x minus z. Now we will try to make each and every expression alike. How and why? Because if we do so, our calculation will be easier, right? That means y minus, this is y minus z. So leave it as it is, take it as it is. Now this is y minus x, but we want to match this y minus x to x minus y. So let's write it as x minus y, but as you are shifting their positions, positions of x and y, so one minus will be coming out, right? The same thing will go for the third expression also. This is z minus x, but this is x minus z. So let's convert it to the expression with alphabetical order, x minus z. So one minus is coming out from here, and z minus y, here it is y minus z. So if you want to shift it to the alphabetical order, then we have to also take 1 minus 1 in common, and this 2 minus 1 together will give you plus 1, right? This kind of arrangement will make our calculation easier. Now here we get a to the power, this from the first expression we get 1 by x minus y into x minus z plus minus 1 by y minus z into x minus y plus 1 by x minus z into y minus z. Now you can easily get the LCM of these 3 denominators. What is it? Yes, x minus y, y minus z, x minus z. So let's write it, because you have to add these 3 fractional expressions, right? So you must find the LCM of the denominators. So this is x minus y, x minus z, y minus z. Okay. Now from the first term we get x minus y, x minus z. So y minus z will be written here. As you know the rule of finding LCM of the fractions. This is minus, because minus 1 was there in the numerator. Y minus z, x minus y was there. So were there. So this is x minus z plus x minus z, y minus z are there. So this will be x minus y in the numerator. So here we get a to the power y minus z minus x plus z plus x minus y. And in denominator we'll get x minus y, x minus z, y minus z. So here we find all the y's are cancelled, all x's are, both the x's are cancelled, both the z's are cancelled. That means 0 by this denominator will obviously give us a to the power 0. Okay. Now here a is a non-zero real number. So obviously something to the power 0 will give us 1. So a to the power 0 will also give us 1. And hence we get the right hand side. This is equals to RHS. And hence it is proved. So see, just by applying the laws of indices step by step and observing every step carefully, we have solved this problem. So in this video, I have shown you how the laws of indices can be applied for solving different kind of problems. Now I request you all to take such examples and try yourself to apply these laws. Just observe the sum what will be given to you and then try to identify that which one of these laws should be applied for solving your problem. Okay. So now in my next video I'll discuss about some other topic and also several examples on different topics. Till then, take care, stay safe.